Hello everyone, myself Swati. Today we are going to discuss about analog circuit. In our today's lecture, we are going to discuss related to active filters. In that active filters, what are the things involved? Just we are going to see one by one. Now let us see about that. First, outline of filter design. In that outline of filter design, just see over here, here that filter is connected over here. First of all, we are applying one input signal to that filter, and here we are observing that output signal. This is a picture diagram related to that input signal, and this is a pictorial diagram related to output signal. In that filtering, certain desirable features are retained and other undesirable features are suppressed. Just see over here, desirable features, that means what are the things or what are the straight line are came over here, just shown here or represented through that line. What is the noise is present over here, that noise is removed from this diagram. Just see. Thus, for the filtering purpose, we are applying some input signal over here, and output is find the structure output we are getting from over here. That is other undesirable features are suppressed over here. In that filter, filters have the property of removing unwanted frequency from one signal. That means, just see in previous lecture, unwanted frequency, that means whatever the noise is present over here is removed in that output signal. According to that, classes are categorized into two different types. First one is the active passive, and second type is related to type related to that filter is a low pass filter, high pass filter, band pass filter. These are the types related to this filter. First, passive filter, that means what is the definition related to passive filters, or how we are going to categorize that filter as a passive filter. Just see here, made of capacitor, resistor, inductors. That means passive filters are those filters which are made from that capacitor, resistor, inductors, like these components are involved in that passive filters. And for the active filter, involving an amplifier, that means active filters are designed by using amplifiers. That means amplifiers again came along with that transistor and amplifier. Op-amp is used again as an amplifier. For that purpose, in our subject analog circuit, we are dealing with only that op-amp. For that purpose, that active filters are, we are going to dealing with that active filters. Then types of the filters. In that types of the filters, low pass filter that removes the high frequency signal. That means in name itself indicate that low pass filter. That means it passes the low frequency signal and it will block out that high frequency signal. According to that, it will be passes high frequency signal and block out that low frequency signal. Then next step is related to high pass filter. In that high pass filter, it removes the low frequency or the DC components and it passes the high frequency signal. Then band pass filter, it removes the range of frequency on the two sides. That means band pass filter will be removes that frequency of the two sides and notches, and notch filter is related to remove the frequency in the middle sides. That means band pass, that means it can be passes the band of that frequency signal and it will be removes all rest of all that signals. And high pass filter, like low pass filter, only the change is that it will be passes the high frequency signal and it will be rejects that low frequency signal. Again, according to that, the classes and the types, here I have shown you that classification of that filters. In that classification of the filters, different categorizations are given. That means signal filtering. That means first of all, in first slide we have seen that filters are classified or filters are designed for the purpose of the simplification purpose or filtering purpose, or we are removing that any kind of a noise is present in that signal, we are removed by using filtering that signal. Then signal filters are again divided into two categorization, that is a analog filter and second one is a digital filter. In that analog filter, that signal again categorized into two steps, that is a element type and the next one is a frequency band. In that element type, that elements, whatever elements are present, that element types are divided into two categorization, that is a active and passive. Just we have discussed. That is a capacitor, transistor, inductors are present in that filter. Then that type of a filter is called as a active filter, and passive filter is related to that amplifiers are designed. The filters whichever are designed by using that amplifiers, that filters are the passive filters. Then frequency band. That frequency band is again categorized into 5 or 6 types. That is a low pass filter, high pass filter, band pass filter, band reject filter, and all pass filters. Like this, that frequency bands are divided. That means low pass filter is related to passes the low frequency signal, high pass filter is related to passes the high frequency signal, band pass filter is related to passes the band pass signal, band reject filter is related to reject that band, and all pass filter is related to passes all the signals. Then here I have given the filter type filters or the types of filters. In the types of filters, here I have shown that is a low pass filter, high pass filter, band pass filter, and band stop filter, and the waveforms related to that all the types of filters. Just see over here, low pass filter. In that case, only the low frequency signals are passed on, and whenever the frequency goes on in the higher ranges, it will be dropped out. And that filter is designed by using connecting. That filter is designed by connecting resistor as a series and capacitor in a parallel along with that any kind of a circuit. Then high pass filter. High pass filter is designed by using, just see over here, again some lower limitation of the frequency. It will be ranges or passes the frequency, and it will be straight out related to throughout that circuit. And that high pass filter is designed by using capacitor and resistor. That in that high pass filter, capacitor is connected in a series and resistor is connected in a parallel. Thus we are designing that high pass filter. Then band pass filter. Band pass filter is designed by using one inductor and one capacitor. These two components are connected in a series and resistor is connected along with that parallel. Thus we are going to designing that band pass filter. Then band stop filter. That band stop filter is designed by using that capacitor and the inductor is connected one by one parallelly, and resistor is connected one by one, and resistor is connected again parallelly with that circuit. Thus we are going to designing that band stop filter. Thus we have designed that all the kinds of a filter by arranging one by one parallelly. Then here terminology in the filter designing. Terminology in the filter designing, there are some important terminologies we are going to use related to designing that filter. That terminologies we are going to see. Just see first terminology, that is a signal to noise ratio, that is a S by N ratio. The S by N ratio is defined by using S by N ratio is equal to 10 log to the base 10 Ws divided by Wn. That means signal ratio divided by noise ratio, and that's here 10 log factor is present. That 10 log factor because of the conversion of that signal to noise ratio in terms of dB. The index terminology is used for the filter designing purpose is a bandwidth. That again bandwidth is a very important parameter for the designing purpose of that filter. Just see over here, in that bandwidth the range of the frequencies of the filter is greater than or equal to 0.707. This is the standard range which is designed for that filter. Then cutoff frequency. The end of passband filter frequencies are the end of passband frequency is the cutoff frequency, and it is a highest frequency. Then breakpoint of the filter. The breakpoint of the gain of the filter is a minus 3 dB overall in every circuit. Then RC filters. That RC filters are designed by using the combination of R and some C component. For that purpose, all or whatever the circuits we are going to designing that filters related parts by using R and C components, that filters are called as a RC filters or the resistor capacitor filters. In a combination with the resistor and capacitor, variations in reactance with the frequency can be used to construct a simple low pass or a high pass filters. That filters are used as a RC filters. That means here the input voltage is applied to that filter. Here we are getting that output voltage. Here we are applying that input voltage. Here we are getting that output voltage. Input voltage is connected throughout that circuit, and output voltage is calculated over here. How we are going to differentiating that filter is a high pass filter and that filter is a low pass filter? Because the RC filter is designed by using only two components, that is a resistor and capacitor. And here the high pass filter and a low pass filter, whichever we are going to designing, that again it is designed by using that resistor and capacitor only. But for the connection or the place of that capacitor and resistor is changed, then the type of a filter is automatically goes on changes. That means here we are connecting that capacitor is the series and our resistance is a parallel, then for that purpose that type of a circuit is called as a high pass filter. And whenever we are connecting that resistor is a series and capacitor in a parallel, then that type of a filter is called as a low pass filters. Then V out is equal to V in into RZ. V out is equal to V in into ZX. Xc divided by Z. This is related to output voltage and this is related to input voltage. Then Z is equal to R square plus Xc square, and Z is equal to here R square plus Xc square, where Xc is equal to 1 upon 2 pi Fc, and here Xc is equal to 1 upon 2 pi Fc. Same that is a calculation of that frequency, and all that Z parameter and output voltage is measured in terms of resistance and inductance also. The same parameters are used for that high pass filter and low pass filter. Then the passive high pass filters. The passive high pass filters, it is designed by using this curve. Just see over here, for y-axis output voltage divided by input voltage, that is whatever the output is coming over here, we have shown that in a y-axis, and for the x-axis that angular frequency is shown over here. In a stop band is from 0 to some frequency, that is a Ws, that is a Ws is a stop band frequency, and the pass band is from the frequency Wp to infinity. That means it is a pass band frequency up to Wp means angular pass band frequency, and Ws it indicates that the angular stop band frequency. Extending from this range, all the frequencies are passed out, and apart from this Ws, that is a stop band frequency from 0 to Ws up to this range, that frequencies are stopped. In a practical circuit design, the engineers choose the amplitude gain of 0.95 for the passive CR filters. In that, capacitor is connected in a series and resistors are connected in a parallel. Here we are applying that input, and here we are calculating that output voltage. Then design of the passive filters. In that design of that passive filters, just see over here that passive filters are designed by using that whatever the components, that is the resistor, capacitor, inductor, amplifiers like this. But for the only resistor, capacitor and inductor purpose, whenever we are designing that any kind of a circuit, then that type of the circuit is called as a passive filters. Just see here, the amplitude response for that passive filter is a V out divided by V in is 1 divided by under root of 1 plus RC omega bracket square. The amplitude gain, that is the amplitude gain of that passive filter, is represented by the letter G. G is equal to ZL divided by ZF plus ZL. This is the transformer function related to that passive filter. It is calculated by the formula HJW is equal to 1 divided by JRC omega plus 1. This is the factor related to that transformer function related to that passive filter. In this, the 3 dB gain value, it is a breakpoint value, and that breakpoint value is calculated by the formula, that is the frequency in a 3 dB is equal to 1 upon 2 pi RC, and we know very well that RC factor is nothing but tau factor. For that purpose, that RC is replaced by the tau factor, and the formula came into picture. It is a 1 divided by 2 pi tau, and total signal transformation formula related to that factor is HS is equal to 1 divided by RCS plus 1. Then next is a higher order filters. That higher order filters is related to order wise differentiation. That means how many circuits we are going to connecting RC combinations related to any kind of a one op amp, then that type of a circuit we are differentiating, or we are calling that is a order of that particular circuit. For that higher order filters, just see over here. Here the resistor is connected in a series and capacitor is connected in a parallel. Here we are applying that input voltage, and here we are getting that output voltage. Here also we are getting applying input voltage, and here we are also getting that output voltage. It is a first order RC low pass filter, and here is a second order low pass filter. Just see over here, here only we are connecting only one R and C component. For that purpose, here we are defined that order of the filter is a first order. And just see in a second diagram, here we are connecting two RC components, that is the resistor capacitor C1 R1 and C2 R2. For that purpose, this order of a filter is designed as a second order RC low pass filter. In that, the higher order of the filters, the closer it approaches in ideal characteristics. This is related to higher order filters. The next parameter is related to active filter. We know very well active filters are related to amplifiers. In that, active filters employ op-amp to attenuate the select the frequency and amplify the signal during the filtering process. The Q factor of the filter is defined as the ratio of the center frequency Fc to the bandwidth Fh minus Fl is equal to Q is equal to Fc divided by Fh minus Fl. Fc is the center frequency, Fh is a lower frequency, minus Fh is a higher frequency and Fl is a lower frequency, and Fc is a center frequency, and Q is a factor of filter. Then depending upon this, here we have shown, or I have shown, that is the active filter first order, second order, third order, fifth order, how we are going to designing that active filter cascading that low pass filter is a. For that low pass filter, we know very well, whenever we are going to connecting that RC component, R component is always in series and C component is always in a parallel. Just see over here, we are using only one RC component. For that purpose, this order of that op-amp is a first order. For this, the second order, because here we are using two R and C component. For that purpose, this order of that filter is a second order. Here we are using three R and C components. Just see over here. For that purpose, this filter is we are going to call as is a third order active filter. Then here we are using 5 R and C components. For that purpose, the order of that filter is a fifth order low pass filter. Like this, the order will be goes on changing day by day. Then low pass active filter, how we are going to defining that low pass active filter? We know very well, for the low pass filter, the capacitor is connected in a series parallel and resistor is connected in a series. And for the low pass filter designing purpose, whatever the aim related to that low pass filter designing is, it passes the low frequency signal and it blocks the high frequency signal. The passive filter takes up lot of space in the circuits and causes the signal to be lost. Combining a passive RC filters with an op-amp for application creates what is known as an active filters. By the active, we mean that the filter requires power to operate. Here is an example of an active low pass filters. The signal is provided the nominated input through a RC low pass filters made up of R2 and C2. Feedback to limit gain comes through C1 and RF. The parallel combination of C1 and RF presents an impedance which decreases with increasing the frequency, meaning that more negative feedback is provided to inverting input at higher frequency, reducing the gain at those frequencies. Then design of low pass active filters. In that design of that low pass active filters, just see over here, low pass active filter, that means the resistor is connected in a series, capacitor is connected in a parallel, along with that RF, CF are the feedback factor related to that filter. Then minus 3 dB cutoff frequency is just shown here. This is a higher level frequency related to that low pass active filter. That is a higher level frequency is FH is equal to 1 divided by 2 pi RF C2. Then DC gain is defined over here is by using the formula KLF is equal to minus RF by R1. Then example, in this example we know very well, design a low pass filter with a cutoff frequencies of 5 kHz and a DC gain of 10. Two equations there we are going to know, that is a transfer function related to that low pass active filter is equal to KLP omega 0 S plus omega. In that, high pass active filter is also one important parameter related to this filtering circuit. In that, just we are seeing here we have applied, that is the input signal related to non-inverting terminal of the op-amp, and here we are getting that output signal from that non-inverting terminal of the op-amp. Here C1 and C2 is connected, and here R1 is connected along with the RF, that is a feedback resistor along with this path. Here is an example of an active high pass filter, that is a C2 and R2 makes up an RC high pass filter. At the input of the op-amp, R3 provides a path of the input when the frequency is too low for C2 to freely conduct when the input signal passes through R3. Instead of the input into the amplifier, the output is tied directly to the input and the gain is a reduced. So these amplifiers have low gain at a low frequency and a high gain at a high frequency. That means gain and frequencies are both directly proportional to each other. Whenever we are going to increasing that frequency, the gain will be increases. Whenever we are going to decreasing that frequency, the gain will be also decreases. The C1 prevents an AC at the input from beginning coupled to the output. Then design of a high pass active filters. In that minus 3 dB cutoff frequency, FH is equal to 1 divided by 2 pi R1C1 and DC gain is given by the formula KHP is equal to RF divided by R1. Two equations there unknowns. Select one component based on the other conditions and determine the values of the other two components. This is the selection parameter related to active high pass filter. Along with that, C1 and R1, RF along with that, A and B factors are given over here. V out is measured over here. Then the transfer function related to KHP S divided by S omega 0. This is the filter classes. Then filter classes is used for that filtering purpose. A filter of a given order can be made to approximate to ideal characteristics is a number of ways depending upon the values of the filter components, or say depending upon the filter classes. Two useful classes are the Butterworth maximally flat and the Chebyshev equal ripple filters. N is the filter order. Then the Butterworth filter related to that filters is V out divided by V bin is equal to 1 divided by 1 plus Fc raised to Yf divided by Fc raised to 2n. That is a Chebyshev filter related to that output voltage is given by the formula V out divided by V in is equal to 1 divided by 1 plus E square Cn square F divided by Fc. Then the higher order active filter related to this filtering design purpose, just see over here. It is a filter classes, that is a R1, R2, C1, C2, K. That means here we are going to use that second order active filter, and the Butterworth values related to these filters are 1.59. Then the Chebyshev value 1 dB ripple factor related to that higher order active filter is a 0.94, 0.972, etc. The above list gives the gain of the component value for one of the main choices for WH is equal to 1. You may find more combinations from the filter design handbook. And just see over here what they shown here. The input voltage is applied over here. Here we are using that C1. Here we are applied that is R1, R2 for that RA-RB combination, and the gain is equal to constant K factor, and whatever that K factor just shown you over here, K is equal to 1.59. Then next parameter is related to active filter, that is a high pass filter. How we are converting that active filter into high pass filter? That active filter is converted into high pass filter by changing only the capacitor and resistor position. Just see over here. Here that resistors are connected in a series. Instead of that, how we are converting that active low pass filter into high pass. Just see over here. Here R1, R2 is replaced by C1, C2. Here C2 is replaced by R2, and here C1 is replaced by R1. That means whatever things we are going to connect in that particular circuit, the capacitor is replaced by the resistor and resistor is replaced by the capacitor, and the circuit will be interchanged along with the function, that is a high pass to low pass and low pass to high pass. Then the combination of the all these high pass and low pass filter is shown over here. Just see here, it is showing that it is a increasing order, it is this in this type, that is a decreasing order, and that is a U-like shape is created over here along with that high pass and low pass filter combination. Then the active filter, that is a band pass filter. Band pass filter, that means whatever the band is we have selected for the transmission purpose, that only band is passed throughout the circuit, and rest of all the band is rejected from that circuit. Just see over here, it is a factor, and it is also another A factor, that is A is measured in a dB. This A is measured is also in a dB, and the whatever the part is remaining or cropped out from this structure, that part is we are going to use for the representation purpose. Just see over here, that is a R and C component, that is a C component, that is a 2R component. Here we are connecting, that is a R, here we are connecting 2R, it is a R1, and here we are connecting, that is a R out. Then this is the active filter, band reject filter. Band reject filter, that means where these filters are designed for the rejecting purpose. That means whatever the band is selected, we are going to rejecting by using the 2R, 3R and C components. The C over here, C, 2C R divided by 2 factor, and thus we are going to rejecting that band reject filter. And this is all about the basic structure related to that filter designing purpose, and whatever the output came from that, all the types of filters just I have shown you over here. From next lecture towards, we are going to see these kind of filters detail one by one. Okay, thank you.